This is AP Calculus Worksheet 7-4 Solutions. So for number 1, we need to find the critical values, or the places where the function intersects the x-axis. So to do that, I need to go ahead and plug it into my y equals function. And this is the same thing from our notes, so hopefully you already have this entered. So this is going to be natural log of x squared minus 3x plus 3. And the window is going to be, it's from 0 to 5, but I like going from -1 to 6 because I'll get to see the entire window. And then I'm going to zoom 0, so zoom to make sure that everything is fitting. Over here it says it's loading, so it's still working. And it's starting to graph it. Alright, so I note that there are 2 places where it looks like it's intersecting the x-axis. It looks like it's 1, 2, and that's 3, 4, 5. To check, you can actually hit trace, and then you can enter an x value. So if I hit 1 and hit enter, it is indeed y equals 0, and if I hit 2, it is indeed y equals 0. So I don't actually have to go to second calc 0. You don't have to do that at all. You just need to trace and check first. That's a little bit simpler. So I know that my critical values are x equals 1 and x equals 2. I guess this was really t, but the calculator only uses x. All of these have the same start position, so all of them start at 8, start at 8, and start at 8. As a reminder, the values that we need for t are the start and end, along with any value that is intersecting the x-axis for velocity when you go backwards, because that will be a critical value. All right, we're going to add all of these with the integral, the position change between 0 and 1. 0 and 1 of that function vt. And remember, vt is really this function up here, dt. This is going to be the integral between 0 and 2, vt dt. And this is going to be the integral between 0 and 5 for our velocity function with respect to t dt. And now we actually have to calculate what those are. So to calculate this integral, I'm going to, well, I guess, did we do the first one already? It did, okay. Anything from 0 to 0, when it's the same number, then it's 0, so it's just 8. For this next one, what's going on here? For this next one, I'm going to go second trace, so the calculation, and I need to calculate the integral, so I'm going to hit 7. And it's asking for the lower limit, so it's between 0 and 1, so lower is 0, enter. Upper is 1, enter. And it's going to shade in this area. It's going to tell us that's 0.5548, so round to the 3 decimal place, 0.555. So 8 plus that is 8.555. So this is going to be 8.555. And I'm going to move this over here. Now I need to calculate between 0 and 2. So again, second trace to calculate. Then I'm going to hit 7, and lower is 0, enter. Upper is 2, enter. And remember that it's always going to be 8 plus whatever it gives us. So it's 8 plus 0.369 if I'm rounding. So it's 8.369. Good. And between 0 and 5, so second trace, 7, 0, enter, 9, not 9, sorry, 5, enter. That would have been way wrong. 5, enter. And it should stop right here. It does, and it says it's 4.73. Remember, we have to add that to 8, so it's going to be 12.739. Oh no, rounding up, so it's going to be 12.740. 740, rounding to that 3rd decimal place. On to number 2. So we have a new equation. Let's go ahead and enter that. We don't know what the critical values are here, so if I come up here, I'm going to go y equals, let's clear out of that. Our new function is sine of t squared, so I'm going to hit sine x squared, and my window is going to be set from 0 to 3, so I do -1 to 4 just to see everything. This might make it confusing though. Zoom 0 to zoom to scale. This might make it confusing because it'll go up and down maybe too many times out here on the right. I just know that the end is right here because it goes to 3. So end's right here at 3, and then don't worry about these dips at all. Perfect. So I need to calculate where those zeros are. I need to find that 0 on my calculator so I can plug that in here. So to find that 0, well, let's test. Is it like 2.75 or something easy? Let's do trace, and let's bring this up here. 2.75 is something nice. Oh wait, that's, sorry, 1.75. Let's try 1.75. And no, it's not exactly 0. So we actually have to find it. So to find it, we do second trace to calculate, and we're calculating 0, so I hit 2. And I know to the left is right there. The right bound is right there. Do our guess is right there. Hit enter. And it says that our 0 is 1.772. So 1.772, and no, I only need another 0 because the last 0 is actually an end point. So I just need one more point in here. So we'll eventually need this point exactly. I guess it doesn't really need to be exact as long as you keep it 3 decimal places. This isn't necessary. But if you want to store this number exactly, this is how you do it. So you get out of this by hitting second mode to quit. And right now, the answer is that x value. If I hit second answer, that is the last value that I entered, 1.772, and it goes on and on. So to store that, I do that answer, and I hit the store button, store, and I don't think storing in x and y works, but if you store in a, notice a is green, so you hit alpha math, store to a, and hit enter. Now a holds the value of 1.772. Perfect, so I'll eventually need this later. So if I go up and look at my graph, I need to grab that point, and so I'm just going to have to calculate that again. So second calc, or second trace, and I'm calculating a 0. So let's scroll over here. That's a good left boundary, hit enter. I need a right boundary, hit enter. My approximation is right there. It's going to tell us 2.507 if I'm rounding. So again, I'm going to store that by doing second answer store alpha apps to store in B. Now A and B hold those good values, and I should write this down in my solutions here too. 2.507. Perfect, and all of them have the same start position. They all start at position 5 at time 0, I believe. Yeah, at time 0 it's equal to 5. And it's asking when it's farthest to the right. Ooh, did the last one ask when it's farthest to the left? We didn't actually answer this. It's farthest to the left at position 8. So at when is not asking 8, so when the answer is at t equals 0. That's the final answer. Sorry about that. And on to number 2. So now I'm going to be adding the integral between 0 and this number, 1.772, and it's the same function, velocity with respect to time, dt. I can go ahead and set up all of these integrals as well. So this integral is going to be between 0 and 2.507 for our velocity function with respect to time, dt, and integral from 0 to 3 of velocity, dt. Okay, so how do I enter this on my calculator? So you don't need to hit graph, but just to see what's going on, I need to somehow find the area between the curve up to this point. The way that I do that is I hit second trace, and I go to 7 to find the integral. The lower limit is going to be, it's a little bit off the screen here, the lower limit is going to be 0, and the upper limit is going to be 1.772. Remember, we store that in A, so if I hit alpha A for the upper limit and hit enter, then it will be exact, and it'll go all the way to that point and tell us that's 0.894 or 0.895 if I'm rounding. And remember, we need to add that to 5, so let me move this over here. If I'm adding that to 5, this is going to equal 5.895. Okay, same thing for our next value, so I'm doing second trace, 7, lower is 0, upper is B, we stored in B, so alpha apps, and it's scrolling through here, and then it's going to scroll over here, good, and all of those add up to 0.43. It is a little bit lower, that makes sense because we have a negative area down here, and when we add 5 to that, we get 5.430, and finally from 0 to 3, so second trace, 7, 0, enter, 3, enter, and it'll get that last bar, and that's 0.77, so it's going to be 5.774, and it's asking farthest to the right, so we're looking for the biggest number, and the biggest number is this value, and it's asking when. It's not asking what is the farthest position, it's asking when is it, and the when is 1.772 seconds. So the answer is, I can write it down here in red maybe, at time equals 1.772, and I'm guessing seconds. Does it say what our units are? We don't know what our units are, so it's just that number without units. And on to number 3. So number 3 isn't a table question. You're just straight on doing how much we've changed in position. So it gives us our initial position and it tells us velocity. In order to find total position change, we'll have to integrate this. So what do we know? We know that we have a start that's given to us. We'll eventually need to find the change, the total change in position. That's what that stands for, and that will give us our ending position. So to do that, what is our start? Our start is position 2, so it's going to be 2 plus, and the change is going to be the integral of this function. So the integral, oh, that's a horrible integral, the integral of our velocity function, dt, and from where to where? So at time equals 0, this is the start, so that's the start time is 0, and the end time it gives us right here, that's the end time, and that's 3. And that will be the answer. So how do we do this on our calculator? There are a few ways to do that. So first of all, I could just go ahead and enter it right here without entering it into my y equals function. I'll show you what that looks like. I think that is actually the quickest way, but if you're used to entering it in y1, I'll show that really quick too. So the quickest way to do this is to go to math, you hit 9, that's the integral, and you're saying, oh, actually the quickest way is 2, we're going to add the 2 plus the integral. So 2 plus the integral, math 9, of this thing. So now I have to actually type in the function here. So to type in a cube root, you can either do to the power of 1/3, but the quicker way I think is doing math and then 4 for the cube root. The cube root of 1 plus t squared, and the parenthesis there. And that is the function. Then we do comma, and then we do with respect to x, then we do comma. Our starting is 0 to 3, so 0, 3, 0, 3, and it'll pop out an answer, 6.551. Remember, we already added the 2, so we don't need to do that. The calculator did the heavy lifting, and this is 6.512, I guess, if we're rounding. Let me show you that we can still get that using another method if we put it into y equals. So if we enter the equation here by going math 4, and then we do 1 plus this t squared. So now it's entered into y1. So again, we probably still want to do 2 plus and then the integral, so math 9. The integral of y1. So you hit vars, right, enter, enter, y1. So now we don't have this weird function, we just have a y1, but you entered the rest of it all the same. So y1 with respect to x from 0 to 3, and we get 6.512, the exact same answer. We're on to number 4. So I consider 4 to be the hardest problem on the homework, and it is the most like an AP test. You would see this question on an AP test. So the tricky part about this one is it doesn't just tell us what time to look for, it tells us, oh, it's just the time when the velocity is first equal to 0. We don't know when that time is. So first we need to find that. How do we do that? So let's go to our calculator, and we need to enter the equation to look at its graph, and we'll analyze the graph. So our y equals, we'll clear this. This is going to be equal to cosine of 2 minus our t squared. Okay, so we have our function, and we know our interval, our window, is going to be between 0 and we don't really know when. So let's just go 0 to 4. I think that's a good yes. So I'll go window, we'll go from 0 to 4, sounds good, and then zoom to scale. Okay, so it's right here, right even before 1. We don't need all of that other stuff. So we need to find that 0. The way that we do that is we're going to do a second trace to calculate. We're going to hit 2, and we're going to say our left boundary is going to say, I don't know, 0.25, because that's going to be all the way over here. And then our right boundary, we can scroll over here. It's going to be, we could have just entered 1. In fact, yeah, just enter 1, hit enter, and our guess is right there, sure. Just needs to be in between. So our 0 is 0.655. The way to store that, I'm paranoid about making an error, so I store this value. The way that you store that is second quit. So right now it is, our last answer is 0.655, so I'm going to do second answer, and then I'm going to store that to alpha A, and now it's stored. Perfect. So that is the time that I'm really looking for. So What is its position when the velocity is equal to 0? That's at time equals 0.655 when the point is talking about. But we're asking for the position. It gives us velocity, so we need to take the integral. So to take the integral on this graph, we just need to find this area. The way that we do that is second trace, and then we're going to do 7 to find the integral. The lower limit is 0. The upper limit is, well, we store that, it's alpha A. And it will find all of the area. So the area of that curve is negative 0.183. So the change is negative 0.18. We'll say round that to 4. And again, we are always coming back to that original equation, which is start plus change, and that's equal to what we're looking for, the end position. So what was our start? The start was 3, so it's going to be 3, and then we're going to add this change that we just found, so it's going to be negative 0.184. And if you don't trust yourself to do this, you can make the calculator do it. So if I quit out, the last answer was this thing, and if you don't trust me, second answer, or second negative sign, that is still there. So I can just say, yeah, add that to 3, answer plus 3, and I get my answer as 2.816. So this is 2.816, and we don't have units, so we'll just leave it like this. And on to number 5. So in this one, we're not given velocity, we're given acceleration, but it's really asking, what is the velocity? What is the final velocity? So this is still going to be governed by the equation, which is start plus change is equal to, change is spelled with an E, is equal to the end. And we know what the start is, so the velocity of the particle is 2, so the start is 2, and then we're going to add the change. So it's going to be the integral of the acceleration. Integral of acceleration will be velocity, so acceleration with respect to time, dt. Here's the tricky part. They tell us that it starts at time equals 1. It doesn't start at 0 right here, it starts at 1. And then it's asking what happens, what is the velocity at time equals 2, so that's the ending point, so at time equals 2, and that will give us our final answer. So we just need to plug this into the calculator. So the fastest way to do that, I'm gonna go the fastest way. I'm not going to do the y equals button. So this is going to be, what number are we adding to it again? 2. So it's going to be 2 plus math 9, the integral of that function, and here's the function. It's going to be natural log of 1 plus 2 to the power of x. So that's the natural log function. Good. So comma variable, comma start, comma end, so comma 1, comma 2, and that will give us 3.346. That's the answer, 3.346. And do we have units? No units. So that's our final answer. And on to number 6. So number 6 is kind of a straightforward problem, just like we had in the last one, only we're going from velocity to position. Again, governed by the equation that if we get the start and we add the change, we will get the end. So what is the start? It says the start is position 3, so 3 plus, and the change is always going to be the integral of velocity to get position. It'll be the total change in position. So the integral of velocity with respect to time, dt. And where are we going from? So this is the start from 0, and we're going all the way to 2. So from 0 to 2, 0 to 2, and let's plug that in our calculator. So when we do this, we are starting with the initial value of 3. So it's going to be 3 plus, and this is, we're going to do the integral of that function. So it's going to be math 9, and the function is t, or x in this case, sine of x squared. Okay, that's that function, comma, with respect to x, comma, from 0, comma, to 2. All right, what do we get here? 3.827. 3.827, and that's in like meters or feet, or don't give us units again. So that's just our final answer. And we're moving on to number 7. So we have a particle governed by that velocity. It gives us an initial condition, and it's asking when it is farthest to the right. Okay, so when it's asking farthest to the left or the right, we need to make a table. So in our table, we are going to have values of t, and we know that it's going to be the start. So start is t equals 0, and the end is t equals 3. And we'll have values in between here in case it touches the x-axis. And we know that we're eventually going to do the equation start plus change, and that will equal the end. All right, so now we need to find what our critical values are, if we do even have any. So we need to graph this thing. So let's pull up our calculator and graph that function. So we have y equals, let's get rid of that. We have a negative, remember this is negative, not this, this is a minus. Negative in parentheses t plus 1 in parentheses. That's going to be multiplied by a sign. And we don't need to worry about order of operations here. Everything should be kept straight. So it's going to be t squared divided by 2. All right, there's our function. And we are going between 0 and 3, so I like to just go from -1 to 4 just to see everything. Zoom 0 to scale everything correctly. And that'll hopefully graph it for us. It's thinking over here on the right. It looks like it intersects here at 0. And this is going to start doing some wavy things over here. Cool. All right, so we're looking for places where it touches the x-axis. It touches at 0, but we already have that. That's an endpoint. And it looks like it touches here at 1, 2, 2.5 roughly. Maybe we can see is if I trace and do 2.5, do I get exactly 0? Really close to 0. So I need to actually find what that 0 is for this t value. The way that I do that is I do second trace, and I'm going to calculate the 0. So I hit 2, and I think it's, so that's left. I'm going to go to the right a little bit. And then I'm going to guess it's going to be right there. And it's going to tell us 2.506. This is really close. So this is going to be 2.506. And that's the only 3 values that we need to worry about. Okay, I'm going to store that value because I think I'm going to need it later. So second quit. And I'm going to just hit store alpha math and hit enter. So now A holds that variable that I need on my graph. All right, so I need to set up this table. My start is, what is my start over here? At time equals 0, the particle is at position 1. So the start is going to be 1 for each of these. And I'm going to add the change. Again, it's given velocity, so if I take the integral of velocity, I will get the total position change. And so between 0 and 0 for our velocity function with respect to t, my dt. And that's just going to be 1 because I haven't changed at all. So this is going to be the integral between 0 and this number, which is 2.506, 2.506 vt dt, and the integral between 0 and 3 over there, that's going to be vt dt. All right, so let's calculate this one first. The way that I calculate the integral with a graph is I can do an integral with a non-graph, but since I have it here, it's a little bit faster. So I'm going to do second calc, and I hit 7. Let's get this whole thing on the screen. And lower limit between 0 and this number, which we stored in alpha a, so our alpha math, to get a, and it will shade in this whole area and tell us that that entire area is -3.265. And remember, we need to add that to 1, and I'm going to make a mistake, so I'm just going to quit out of this. I'm going to say, yeah, add that answer plus 1, and I hit enter, and it says, okay, that is -2.265, and we don't need to worry about rounding because that's a 4. Perfect. And finally, we need to take the integral between 0 and 3 right here. So on our graph, this is already highlighted, but we're also going to get that. So we're going to do second trace. We're going to calculate the integral for 7. Lower limit is 0, upper limit is 3, and just let it do its thing. Remember, we still have to add 1 after this. So, oh, it stops right there. Perfect. So you still have to add 1. And if you don't trust yourself, make the calculator do the work. Second quit and just say, yeah, plus 1. And this is going to be -1.197. All right, so now we need to actually answer the question. The question was asking farthest to the right. So right is positive, so which one of these is the most positive? And the answer is that one. And remember that it's not asking for what the position is farthest to right, it's asking find the time. So the time is actually 0. That's the real answer. And let me write that in red. So at time equals 0, farthest to right. And explain your answer. I have this table. I think that is enough of an explanation. All right, that concludes this worksheet solutions. Thank you for watching.